Good morning, student. You are watching You Will Love Math for beautiful mathematics content and beautiful mathematics learning with proper problem solving. So today you can see this is my new board. So in the new board we can discuss the mathematics, the theory, the concept in a more elaborate way. It is a good large area for drawing for different perspective of geometry, problem solving. So the mathematics will be more elaborate, more beautiful, more motivational, and more marvelous in the different approach. So today, what I will discuss three important topics. These are basically division algorithm, second thing is remainder theorem, third thing is factor theorem. So one thing I can tell you that remainder theorem or factor theorem are two sides of a coin. That means if this is a coin, so this side is factor theorem and this side is remainder theorem. Understand? So this side is factor theorem and this side is remainder theorem. So why I am telling this, I will discuss. And the complexity of remainder theorem and factor theorem will be vanished. So now first we will see division algorithm. So you know that there is four things. One is divisor, second is dividend, third is quotient, fourth is remainder. Fine. So there are four things. So what is the relation? If it is small d, if it is capital D, if it is capital Q, if it is capital R. So what is the relation? Hope you know the relation. The relation is very easy. Capital D equals to small d into capital Q plus R. So divisor into quotient plus remainder equals to dividend. Okay. So this is the basic concept or fundamental concept of remainder. So division algorithm. It is the fundamental concept of division algorithm. So now you know this thing. Now we will go the remainder theorem. Okay. So what is remainder theorem? Remainder theorem is remainder theorem. Remainder theorem is basically, understand with me. So if a polynomial px is divided by x minus a and left with a remainder, why I am writing remainder because to R in capital because to highlight or nothing else. Remainder, suppose capital R, then the remainder R will be f of a. Sorry, this function is p of a. This will be the remainder. So how it is coming? From the division algorithm we can write here that px equals to x minus a into q, x plus r into x. Since it is a polynomial of x, so I am writing x in every section. Now if it is dividing, understand very carefully, x is 1 degree polynomial here, and we don't know the degree of x, px, so we can assume the degree of x is n. Fine. So it is 1 degree polynomial. So understand very carefully, the maximum degree of polynomial in that section, x is taken as a 1 degree polynomial. So the degree of that polynomial is x to the power 0 only. So it is a non-x term. Rx is a non-x term, because if Rx there is, if Rx is a term of x, if it is a function of x, then we can divide x minus, you can divide Rx by x minus a, and then that part will be the non-x terms, or x to the power 0 terms. Understand very carefully, since the power of x is 1 here, so the remainder, as per the division algorithm, the remainder, there should not be any term equals to 1 as an exponent here. Sorry, in the power of Rx, there is no term less than equals to 1. It should be less than 1. So if the power is less than 1, and it is, then it will be x to the power 0 only, because we are dividing, it is, the power is not going to negative. Understand very carefully. So Rx is a term whose power, or which power will be less than the power of x, so that it will be remainder. Other, if it is the same as exactly x or greater than x, then the power will be equal. If the power is greater than the power of x to the power 1, sorry, x to the power 1 means 1, then it will divide once again, and the remainder will left as a non-x term. So basically we can write Rx, as R only the non-x terms. Okay, so here it is R, so we can write it again, px equals to x minus a into qx plus R. So since it is dividing by x, so x minus a, so what will be pa will be a minus a qa plus R. Since there is no term x in R, there is no scope of putting value x in R, so R will be same as previous. There is no option to put the value of variable x here. Okay, so now it will be 0, it will be R, that means R. So what we are getting, the remainder is P of A. Okay, so it is a remainder theorem, very important theorem. Most complex part is here, that why Rx equals to R. Since Rx is a non-variable term here, if it is a term of x and we are dividing by x minus a, so the power of Rx will be less than x, or the power less than x means the power is less than 1, so only option is 0. So x to the power 0 is non-variable term is coming here, since we know x to the power 0 equals to 1 for any variable. Okay, so this is remainder theorem, very crucial, very important theorem here. Now we will go to the factor theorem. So what is factor theorem? So I can tell you factor theorem in a different way, that if x if px is divided by x minus a, and if the remainder is 0, r is 0, then it is, we can tell that x minus a is a factor of px. Understand? So how I am telling it is a part of remainder theorem. So write down factor theorem. Okay. So basically, if same px is divided by x minus a, and if p of a is 0, then x minus a is a factor of p of x. How we can prove it? Basically, it is a part of remainder theorem. Why? Because here remainder is coming 0. Here remainder is coming 0. Other thing, we are getting remainder as r, any value rather than 0. Here it is a part of remainder theorem. Understand? So now how can we do that? We know again from the division algorithm, p of x equals to x minus a into qx plus r. I am writing from the remainder theorem as a non-x terms. Okay. So now if it is dividing, then the remainder will be 0. We know that it is completely divisible. So if it is completely divisible, then r will be 0. Okay. So from the remainder theorem we know that p of a will be remainder. So p of a equals to r equals to 0. That means it is completely dividing it. So we can write here px equals to x minus a into qx, and this part is 0. That means we cannot write here. So x minus a is completely dividing px. So factor theorem is a part of remainder theorem. Understand? And the complexity, what I am telling, that it is if it's a coin, this part is remainder theorem, this part is factor theorem. Two sides of a coin, and it's an important theorem. Okay. So three things I have covered: remainder theorem, division algorithm, remainder theorem, and factor theorem. So now I can show one example of remainder theorem. Okay, I can show one example of remainder theorem, that that if x cube plus 5x square plus 7x minus 6 is divided by x minus 3, sorry, x minus 1, you can write, huh? X minus 1 or x plus 1, then find the remainder. So from the remainder theorem we can write, I am dividing here, that we know that x minus a, so here I can write x minus of minus 1 here. So a here is minus 1. So if a is minus 1 here, so put the value of minus 1 here. So minus 1 whole cube plus 5 into minus 1 square plus 7 into minus 1 minus 6. So 1 minus 5 minus 7 minus 6. So sorry, it will be 5, it will be plus 5, sorry, it will be plus 5. Okay. So 1 plus 5, 6 plus 7 minus 6, 6 will be cancelled out. Okay. So 6 will be cancelled out. So minus 7 will be remainder. So by dividing you can get the value. By remainder theorem you are getting the value very easily. Okay. And if I change that, if it is, I can change that 13 plus 7. Okay, plus 7. Uh, that means plus 1. If I am changing the equation like that, plus 1, then x my plus 1 will be a factor. How can I tell that? Put the value of x equals to minus 1, sorry, a equals to minus 1. So minus 1 whole cube plus 5 into minus 1 square plus 7 into minus 1 plus 1. So what will be the case? Minus 1 plus 5 minus 7 plus 1. Okay, so 5 plus 1 6, 5 plus 2, so it will be 3, like, okay, sorry, it will be 3. Okay, so put it here 3. Okay, 3, then x plus 1 will be factor. I am showing an example, and I am making problems right now here. So some manipulation calculation is going on in my mind, and I am writing like that, so to give you a current or live examples. Okay, so in putting the value of x equals to minus 1 here, minus 1 whole cube plus 5 into minus 1 whole square plus 7 into minus 1 plus 3. Fine. So the answer will be minus 1 plus 5 minus 7 plus 3. So here will be plus 3 plus 8 minus 8 0. So from the remainder theorem, putting the value of minus 1 in the equation, it is giving the remainder 0. That remainder 0 means x plus 1 is exactly dividing the px. So if px is here x cube plus 5x square plus 7x plus 3, so x plus 1 is a factor of here, and it is called also a zero factor. That means putting the value of 1 minus 1, you are getting the value of the polynomial 0, so it is also called zero factor. So keep in mind this terminology also. This term is also a part of factor. Zero factor is a part of factor theorem also. So very important topic I have covered today. It is a part of division algorithm, Euclid's remainder theorem. I forgot the name Euclid. Okay, so a tribute to Euclid. You know Euclid as a geometry, as a father of geometry, but he has also contribution in algebra. So right, I'm writing the thing that Euclid's Euclid's remainder theorem is R equals to P of A. Fine. So thanks for watching. You will laugh, man. If you find this video is helpful for your learning, you can share this video to others so that other people can learn good mathematics. Other people can get fun from mathematics by learning mathematics. So thanks for watching for today's class. In the next class, I will come with a different topic, with a different beautiful mathematics. Thanks for today.